LCROSS launched on the same rocket as the Lunar Reconnaissance Orbiter back in June earlier this year. While LRO's mission is to map the Moon, LCROSS piggybacked on the otherwise redundant Centaur rocket stage. The plan was to separate LCROSS from the Centaur and use the rocket stage to impact the lunar surface deep inside a crater near the south pole of the Moon. The much smaller shepherding LCROSS craft was designed to follow close behind, attempting to observe the plume of dust from the first impact in various wavelengths. There would be just a few short minutes for the probe to send the data back to Earth before it too would crash onto the lunar surface. The data could provide much sought-after evidence of water ice. In just a few hours' time, the LCROSS spacecraft will smash into its target crater near the south pole of the Moon. To watch, we've come here, to Palomar Observatory in California. Behind me, in this imposing dome, is one of the world's most famous telescopes, the Palomar 200-inch.
Tonight we're planning a high-resolution movie of the LCROSS impact. So the idea is that most observatories are actually going to be searching for the water in the impact debris using spectrographs. And as we have adaptive optics here, which gives us very high spatial resolution, we're hoping to basically show where the debris is for all the other observatories. So our plan is to use the adaptive optics system with an infrared camera, taking images every 1.5 seconds or so throughout the whole impact.
And you mentioned adaptive optics. What are adaptive optics exactly?
The idea is that the Earth's atmosphere distorts the light passing through it, much like water does, distorting light going through a swimming pool. And we use a deformable mirror that's controlled very rapidly and apply opposite shapes on this deformable mirror to the distortions to cancel them out.
And you have to do that very quickly because, of course, the Earth's atmosphere is changing.
That's right. We have to do it quicker than the wind blows across the telescope, essentially, so about 1,000 times a second. Our entire program tonight is a bit experimental, and so we're hoping it'll work out. We have to lock on a bright sunlit peak on the Moon, which is something that we've only done once successfully before. We hope it'll work a second time.
Choosing the crater which would give LCROSS the best chance of finding water ice caused more than a few arguments. Eventually, the team decided to crash the Centaur into Cabeus, but that's a difficult crater to see from here on Earth. So why Cabeus? Out of all the craters on the Moon, why pick on this poor, defenseless little one down at the South Pole?
It's obviously extremely important when you've got one shot to do this to pick out a crater that's going to be most useful. The first thing, obviously, was to get a permanently shadowed crater. That was the key to the whole experiment, looking for ice. But then you also want to maximize the geometry so that you can see it from the Chase spacecraft, so that you can see it from some of the really big telescopes on Earth, like where we are at Palomar. And then they got into even more details of the geometry so that the lighting, when the plume comes up, not only do you get that sunlit, but you have some of it against a dark background.
So how would the water have got there? It's not from the Moon itself, presumably.
Right. We presume if there is water ice, it's probably mostly been delivered by comets and impacting over the course of the solar system history and depositing their water ice, among other things. And then that water migrating, every time it gets heated up by the sun in the lunar day, it basically vaporizes, and then water molecules go flipping along, and then they condense again in the lunar night, and eventually, the theory goes, they find these nice stable places at the poles in these permanently shadowed craters and may just hang out there for eons.
Tonight's impact is a unique event, so it's not surprising it's attracted the attention of amateur as well as professional astronomers. We're very lucky in that we've been joined by a crack squad of Californian observers and imagers, all here to enjoy Palomar's famous skies. Nice telescope.
Thank you.
It's looking ready for the evening. What are you up to?
Well, right now I'm trying to set up everything I'll need for tonight's event. Hopefully I'll be able to capture it take place. This is a 12-inch telescope, which is the minimum size we'll need for being able to look at the crater area that the impact is going to take place.
To see Cabeus, that's correct. That's the crater.
Yes. And if we're lucky, we'll catch it on film, and some of us will catch it visually, hopefully.
Hiya, can we interrupt for a second?
Sure.
How are things? What are your plans for the evening?
Well,
Unlike most of the folks here, my main emphasis will be getting visual.
Fantastic.
Okay?
Proper
Now,
astronomy.
Well, there's all sorts of astronomy going on.
Sure.
I'm coming up here, and I'm going to be pointed this right at the moon, and I'm going to be just seeing if I can catch this on my homemade telescope.
Fantastic. Classic Dobsonian.
Yeah, it's a classic Dobsonian, and it's a 12.5 incher. This I'm going to remember, I saw it with these Mark I eyeballs.
As the sun sets here on Mount Palomar, you can feel the excitement building. It will still be daylight in the UK at the time of impact, but it should still be possible to see the resulting plume if the NASA predictions are correct. And that's exactly what Patrick's planning to do in Selsey.
We're all down here on the end of Selseyville, and it doesn't look good. Last night was lovely, but I'm afraid at the moment we're clouded out, but we haven't despair yet. Well, what do you think about this, Paul?
Oh dear, it looks pretty hopeless, doesn't it, I think? But it might clear.
You got a drawing last night, Paul, didn't you?
I did, if only we had those conditions now. Seeing's not great. You can see how foreshortened it is on the limb. You'll know that's your time as a moon mapper.
I do indeed.
How foreshortened it is. It's not an easy target.
I think, Pete, you were pretty hopeful, weren't you? Have you had clear weather?
I was very hopeful, Patrick. I've actually got an image which I took
Yes.
the morning before, actually.
Oh,
so that
yes.
was yesterday morning when it was very, very clear.
A big crater of Mauritius.
There, and then this dark patch here is actually where the impact is going to take place. And it's quite easy to find
Yes.
because there is a very distinctive mountain on the limb which picks it out very nicely. But it's a very difficult region of the moon to identify because everything is so foreshortened.
Well, I know the region. I've been mapping it for many, many years, but it's really a difficult one. But if you know that it is there and it's the right kind of crater. All we need is a gap in the clouds. Of course, over in America, because they are almost clear scales and have bigger telescopes than we have.
Indeed.
So they should see it and they should get the analysis, but I still maintain they are not going to find any water. If they do, I really will eat my hat.
Well, the good news is it's a beautifully clear night up here on Palomar Mountain, so hopefully things are looking good for our chances of observing the impact. We've switched to a special infrared camera so we don't disturb the observers, but let's go and see how they're getting on. So how does it look?
Very clear, very stable. Yeah, it's wind has died down, and looking at the region where the cavius crater is, so I should be able to see the impact.
So here it is. Is this the target region?
Yeah, this is. I'm using two reference points, Clavius and Mortis, and this ridge area here. So generally this is probably where Cavius is at, and hopefully, if we're lucky enough, and again, this is not the 200-inch telescope, we might get some of the plume coming off the surface, which would be very exciting for us.
What do you expect to see when the impact happens?
Hopefully something, like everyone else.
Here in the control room at Palomar, it looks like the hours of preparation have paid off. The team have a beautifully clear and stable view of the impact site thanks to the 200-inch telescope, and meanwhile, the amateurs outside are readying themselves for this unique event.
30 seconds.
The LCROSS craft separated from the Centaur rocket stage a few hours ago, and both are now on collision course with Cabeus, down near the south pole of the moon. So the rocket should be somewhere in the field of view around now, so just seconds to go. It's there somewhere, heading for the crater. Finally, the moment we've been waiting for.
All stations flight, mark Centaur impact.
Well, I'm afraid the crash is happening at this very moment.
Yeah, we're not sure from NASA whether the impact's actually happened yet or not. It's supposed to have done.
Well, one way or the other, it's exciting.
Yeah, absolutely.